AC waveforms are an integral part of electrical engineering and need to be explained thoroughly and simply. Today we're going to have a quick look at the basic maths behind them, the basic principles, and a couple of equations. AC waves are primarily generated from an AC generator. This is a coil rotating within a magnetic field, and then that just outputs an AC waveform. It's basically the reverse of a motor without a split ring commutator. The AC waveforms are very useful within the household and are used primarily by most large appliances such as fridges, ovens, that sort of thing. Here we have a very basic AC sine wave that we're going to explain very simply. We have the amplitude, it's on the far right. This is the peak-to-peak values, or E peak to peak. E is the voltage of the system. E can often be swapped with current, so the AC sine wave represents voltage and or current. The period is the time taken for one complete cycle, so one trough and one peak. The frequency is then 1 over the period, but we'll get to that later. But basically this is all the basics you need to know of the AC sine wave. Here we have the basic equations of an AC sine wave. So y equals a sine omega t plus alpha. Y is your voltage or current. A is the amplitude of the sine wave. Sine is, well, the trig function. Omega is going to be explained in a second. T is time, that's your x-axis, plus the alpha. Now alpha is the phase difference. We're going to get to that in a second. So we have there omega equals 2 pi f. That's exactly as it says. 2 is constant, pi is a constant, and frequency is found by, guess what, 1 over the period, as shown below. This is all, frequency is in hertz and period is in seconds. Here we're going to explain the phase shift of the curves. Now, cosine and sine are very common mathematical functions. We have the blue curve here representing sine, and the red curve representing cosine. Now, here in this expression, if we were to write the cosine wave in the form of a sine wave, we would have to add on the phase shift of 90 degrees. Therefore, alpha would be plus 90. Now, if we were to write the sine wave as an expression of a cos wave, we would have cos, or y equals whatever the amplitude is, cos omega t minus 90. Therefore, it's lagging by 90 degrees, as shown here. So if you're starting before, you're adding the phase shift. If you're starting after, you're lagging, therefore you're minusing the phase shift. Everything that I've said in these videos need to be applied to both the voltage and current when considering AC circuits, and if you require more information, there is plenty out there on the internet. Thanks for watching.